In theory, farmers could achieve water savings of about 16% by using the automated early cascade irrigation shutoff, or AECIS system, on their conventionally watered rice. That's why researchers are seeking growers willing to try AECIS on their fields, as Joe Massey explained during the online Arkansas Soil and Water Education Conference.
And the key points of AWD rice flood management is that we know that we need to hold the flood for at least 10 days after that initial application of nitrogen pre-flood to stabilize the nitrogen, waiting to draw down the flood depth also allows the canopy to close, helping with weed control. And then the other key aspect with AWD is we know that rice is particularly sensitive to water stress at early reproduction, such as at green ring. So if we take these 2 points and make sure there's water in this catch basin, particularly the first 10 or 14 days after flood initiation and at green ring, the model suggests, and I'm going to show the results here, for a 58-acre field, 10 paddy, straight levee field using 1,200 gallons per minute. The model should suggest that we could expect about a 16% water savings, again, when we add water back to the AECIS system at those critical times. This data is using 35 years worth of rainfall data, and so it's averaging across dry years, normal years, and wet years. So the model is estimating 31 inches applied to Cascade, 24 inches applied according to using MIRI, and then AECIS is somewhat in between at 26 inches. That represents a 60% savings over Cascade. The blue bars are the runoff estimates, and again, that's kind of what the system would be trying to reduce. And in fact, we see that we get about an estimated 50% reduction if we use those lower 2 paddies as a catch basin, again, adding water back at the critical times. Versus 12 inches runoff from the Cascade, 6 inches from AECIS, and 4 inches estimated from MIRI. And then the key question is, okay, but what happens to the flood depth in the 10th paddy? And in this particular model setting, we were targeting a 4-inch flood in that bottom paddy. So these are average paddy depths over an 85-day irrigation window or irrigation season. And so for comparison, the Cascade averaged 3.5 inches over that 85-day period. MIRI, which does a little better job of maintaining the flood height at an even level, 3.8 average, and the AECIS estimated 1.5 inches. In theory, according to the model, that's enough to keep a standing flood on the field most of the time, but clearly there's going to be times when it could go down, and that's why we need to field test this. And again, we're looking at 2 inches average flood depth in the last paddy serving as a catch basin versus about 4 inches in the Cascade and MIRI system.